Let's take a look at your MT11 LT5 seminar on cross-sections and solids of revolution. Before you start, do the first 5 questions, and then we'll either review them in class or use them as prior knowledge to help you out. What we're going to do is we're going to identify shapes of cross-sections formed by cutting a solid with a plane. And we're going to identify 3-dimensional objects generated by rotations of 2-dimensional objects. Now, a cross-section is where I take a plane and I slice through my solid, and then imagine if this solid was made of sand or clay would be a better way. You slice through it with a knife, you open it up, and you look at what kind of 2-dimensional shape do I see? You can see on this first one, where it crosses, I'm going to get a rectangle, aren't I? Because it's parallel to the base. And then on our next one, we get a different shape there. And then our third one, too. And what happens, it all depends on the angle we slice that plane through, and then how many sides does it touch? Because that'll tell you the kind of shape. If it touches 5 sides, it'll be a pentagon. If it touches 3 sides, it'll be a triangle, and so on. And then we have symmetry with a plane. That is, I would just slice through that and notice it would match up with everything. So you have plane symmetry. So if I take a look at example 1 here, I've got this rectangular prism, and then if I slice it parallel to the bases, I could get one type of symmetry, because it would be the same. We'd have to go through the middle. And then we'd have a vertical slice. That would be symmetry. And then your horizontal slice. So we have 3 of them. And then a cross-section of a cone is called a conic section. Cone, conic, see how they're related? What happens is all our major shapes in geometry show up with a cone. That's why we call it conic section. So if we take a look here, if I intersect it parallel to the base, I'm going to get a circle, because notice we got this circle here. And then it's going to be parallel all the way up until you get to the top. Well, then it'll just be a point. If I slice it perpendicular to the base, so straight through the base perpendicular to it, I'm going to get a shape called the hyperbola. It kind of looks like a parabola, but it has different properties. And usually what happens, you'll get 2 of them across from each other. And then if I slice it with the same slope as your slant height, well, there is your parabola from Algebra 1 we're used to seeing. And then if I slice it at an angle that's different than the slant height, I'm going to get an ellipse. An ellipse kind of looks like an elongated circle. Those are your 5 major equations you'll learn in Algebra 2 or pre-calc. These are called conic sections, and they each have, just like a line has an equation, and a circle has an equation, a parabola has an equation, and then we also have equations for ellipses and hyperbolas that you'll learn about. Okay, now, axis of symmetry is when I rotate it around. That's your axis of symmetry, where everything lines up to itself. The important thing to remember when you do an axis of symmetry is it's like a lathe. It turns around. Now, I'm not very good at drawing, so that's why I put this one in here. But you're never, don't tell me you get a cube, because you're turning it. That's what axis, that's what rotation means. I'm turning it, and so I'm turning it through space. So on this case, if I take my rectangle and I turn it through space, I'm going to get a cylinder. And that's it. I don't know why I got extra pages on here, but that's it for our seminar.